Did you know that DNA's nucleotide sequence can be translated into music? In 1986, the forward-thinking Japanese geneticist Suzumu Ono opened our ears to the melodies hidden within our very cells by transposing the nucleotide bases G, T, C, and A into the musical notes A, C, G, and D, respectively. This fascinating discovery raised a resonant question. If DNA can be transformed into music, could music have the power to influence or even alter our DNA? Sound, as we have come to understand, carries weight, possesses the marvelous ability to move matter. Diving deep into the study of cymatics, the science of visualizing sound, we venture into unknown territories, exploring the potential harmonic influences of music on our DNA. Could we be on the cusp of unveiling the therapeutic potentials of music as a tool for healing? The investigation into this harmonic interplay could pave the way for breakthroughs in harmonizing our health and well-being. Suzumu Ono's groundbreaking research in transforming DNA sequences into harmonic compositions ushered us into a world of uncharted prospects. Through pairing distinct musical notes with nucleotide bases, Ono unearthed the innate musicality present in our genetic blueprint. This revelation did not just captivate imaginations, but also stimulated deep reflections regarding the biodirectional relationship between DNA and music. If DNA, the primal blueprint of life, can morph into music, what latent effects might music harbor on our genetic fabric? Ono's methodology of translating DNA into rhythmical melodies illuminated the fundamental correlation between the intricate lexicon of genetics and the universal dialect of music. DNA, with its quartet of nucleotide bases, adenine A, cytosine C, guanine G, and thymine T, presents itself as a grand orchestration of genetic data. Each base commands a unique role, drafting the genetic directives that carve an organism. Linking these nucleotide bases with musical notes, Ono fostered a deep synergy between the spheres of science and artistry. This transformative process birthed not only captivating harmonies, but also divulged deeper cognizance of the intrinsic musicality housed within our genetic code. This insight fueled an intense curiosity around the mutual influence between DNA and music, inciting questions about music's potential to alter our genetic structure. Given the detailed nature of DNA and the depth of musical compositions, it's intriguing to hypothesize the prospective impact of music on our DNA. Music, a potent conduit of emotion, renowned for its power to invoke physical and psychological reactions, transcends language and cultural boundaries, arousing joy, serenity, exhilaration, or reflection. Could it harbor the potency to affect our DNA tangibly? Though scientific consensus remains nascent, initial investigations hint at music's capacity to steer genetic expression and cellular activities. The discipline of epigenetics probes the forces outside DNA sequencing that govern gene expression, underscoring the role of environmental triggers and lifestyle choices in altering gene manifestation. Sound, in its role as a stimulus, might harbor the capacity to initiate epigenetic shifts within our cells. Moreover, recent studies depict sound waves' influence over cell behavior, with specific frequencies shown to promote or halt cell growth, steer protein creation, and regulate neurotransmitter discharge. These discoveries hint that music, a symphony of harmonized frequencies, might hold the potential to interact with cellular operations, inclusive of mechanisms linked to DNA, unveiling a foreign yet familiar territory of exploration. The discipline of cymatics presents a riveting insight into the interplay between sonic vibrations and the emergence of detailed geometric configurations in diverse materials. Through the analysis of the visual imprints left by sound waves in mediums like sand or water, scholars have unearthed astonishing facts regarding the vibrational forces propelled by sound. This foray into cymatics propels us to ponder deeply on the potential repercussions of music, which is constituted of elaborate sound waves on the human anatomy, inclusive of our DNA. Cymatics illustrates that distinctive sonic frequencies have the capacity to forge hypnotic patterns in substances. As sound waves traverse a medium, they investigate vibrations in the particles within that environment. When these vibrations find structure and synchronization, they take the form of detailed geometric designs that become a subject of scrutiny and analysis. The realization that sound waves bear the strength to materially alter objects encourages us to hypothesize that music, embodying a rich and intricate assembly of sound waves, might hold the potency to shape not only our tangible environment, but also the fundamental fabric of our existence, our DNA. When we immerse ourselves in music, we often find ourselves amidst a cascade of varied frequencies and resonances. Every musical tone aligns with a distinct frequency and wavelength, weaving a multifaceted soundscape. These musical oscillations, akin to all sound waves, stand to influence our psychological structure at a primal juncture. Nestled within us, DNA operates as the manual for life, harboring the genetic directives that define our identity. It is structured with nucleotide bases, each exhibiting unique vibrational characteristics. Considering that sound waves can modify vibrational patterns in substances, it becomes plausible to speculate that music, a labyrinth of sophisticated sound waves, may modulate the vibrational demeanor of our DNA. This speculation regarding the persuasive role of music on DNA invokes the theory of resonance, a phenomenon where two entities with comparable frequencies stimulate each other, initiating vibrational responses in one another. There exists a possibility that the resonating frequencies in music might forge a harmonious dialogue with the vibrational frequencies residing in our DNA, fostering harmonious resonance at a cellular level. Should music indeed bear the capability to modulate the vibrational status of our DNA, it signifies potential repercussions on gene expression, cellular operations, and ultimately, our holistic health. This unfolds a pioneering horizon for leveraging music as a remedial instrument, endowed with the power to reinstate equilibrium and facilitate hearing at a foundational tier. The scrutiny of sound and its vibrational impact on the human body encapsulates a rich field of research. A captivating segment within this domain is the practice of sound therapy, renowned for its efficacy in fostering relaxation, alleviating stress, and bolstering a sense of wellness. It has been documented that the distinctive resonant frequencies emitted by a range of musical instruments can incite diverse psychological reactions in people, underscoring the deep-seated influence of sound and vibration on our bodily systems. Turning our gaze towards the interplay between sound, vibration, and DNA, it becomes paramount to appreciate that DNA transcends a static molecular structure. It thrives with innate vibrational frequencies pivotal to its operation. These frequencies are cardinal in safeguarding the stability and integrity of our genetic framework. Interference in these frequencies could precipitate genetic disruptions or variations, implicating notable repercussions for our health and wellness. With an acknowledgement of DNA's vibrational attributes, it emerges as a reasonable proposition that music endowed with a potent vibrational essence might engage profoundly with our genetic matrix on a foundational plane. Music, a rich tapestry of sound waves, engenders vibrations capable of traversing our bodily landscape, reaching into the depths of our cellular composition. In this lens, music evolves into a conduit, potentially harmonizing with the vibrational rhythms of DNA. Such harmonization beckons a consideration that the resonant frequencies woven in music could find a symphony with the vibrational currents coursing through our genetic fabric, fostering the grounds for physiological and even epigenetic transformations. The science of epigenetics, focusing on inherited shifts in gene expression, sans changes to the DNA sequence, offers a scaffold to delve into the prospective implications of music on our genetic narrative. Influenced by a spectrum of external vectors, including environmental cues, lifestyle predilectors, and possibly sound vibrations, epigenetic alterations pave avenues for music to sculpt gene expression, thereby steering cellular dynamics and overarching physiological responses. This burgeoning perspective unfurls an intriguing avenue for exploration, envisaging music as a therapeutic agent bearing the promise to foster well-being and re-establish harmony in our physiological orchestration. From the epochs of ancient civilizations to contemporary eras, music has incessantly danced with notions of healing and rejuvenation. Bygone societies venerated the therapeutic potency dwelling in distinctive melodies and rhythms, crafting music to foster physical vitality and emotional equilibrium. Recent scientific ventures have illuminated the physiological resonance of music, unveiling its prowess to modulate bodily functions dynamically. Intriguingly, indulging in musical experiences has demonstrable influences on heart rate, blood pressure, the flux of stress hormones, and the vigor of the immune system, unveiling music's sublime interaction with our physiological theater and steering our health and wellness trajectories. This exciting realization fosters a reasonable curiosity. Could music wield the power to affect our DNA, the molecular manuscript for life? DNA, the cardinal architect of life, orchestrates our genetic landscape and governs our cellular choreographies. It radiates with vibrational frequencies that could potentially be the nexus of music's interactions with it. The proposition gains traction when we consider that dissonance in these vibrational cadences can engender genetic aberrations and imbalances. Could it then be possible that calibrated musical frequencies find harmony with DNA's vibrational pulses, restoring equilibrium in our genetic canvas? Bioacoustic research hints at a positive conjecture, presenting a scenario where distinct frequencies and harmonics can echo within specific bodily realms, orchestrating a symphony of wellness. Analogous to a virtuoso tuning their instrument to craft harmonious melodies, we can envisage music, meticulously crafted, resonating the DNA's vibrational tempo, conjuring a dialogue of harmonies at a molecular level. Venturing beyond speculative territories, tangible evidence underscores music's potential healing embrace on DNA. Scientific inquiries affirm that music therapy can sway gene activities linked with stress reactions, inflammation, and immune functionalities, heralding the prospect of music orchestrating epigenetic metamorphoses, reshaping gene expression landscapes while preserving the DNA sequence sanctity. Moreover, the nascent field of psychoneuroimmunology weaves a narrative of the intimate entanglement between the psyche, physiology, and immunity, portraying music as a potent elicitor of emotional and physiological reverberations, which in turn have the capacity to sculpt immune responses. This fertile ground of exploration magnifies music's prospective role as a healer, echoing harmonies that could reshape the narrative of our very DNA. our frequency garnering notable interests at 432 Hz. Enthusiasts of this frequency assert it resonates distinctively with the human psyche and the intrinsic rhythms of nature, fostering harmony and equilibrium in our DNA. They posit that immersing oneself in music orchestrated to 432 Hz can kindle a deep-rooted sense of well-being and potentially aid cellular restoration. Furthermore, audio-centered therapies like isochronic tones and binaural beats present in additional avenues to delve into these precise frequencies. Isochronic tones manifest as singular tones, pulsating intermittently at designated intervals, while binaural beats are cultivated by transmitting marginally diverse frequencies into each ear, giving rise to the perception of a third harmonic frequency. These modalities can target definitive brainwave patterns, ushering in states of relaxation, heightened focus, or amplified creativity. Solfeggio frequencies encompassing 396 Hz, 417 Hz, 528 Hz, 639 Hz, 741 Hz, and 852 Hz have also piqued curiosity lately. These frequencies, hailed for their distinctive attributes, are purported to harmonize with various facets of well-being. Each harmonic is aligned with individual purposes, such as expelling negativity, facilitating transitions, bolstering DNA repair mechanisms, nurturing relationships, fostering intuition, and igniting spiritual awakenings. While the idea of modifying DNA with distinct frequencies is yet a field in continual research, the possibility of affecting our health at a molecular grade is both enchanting and uplifting. By employing distinct hertz, such as 432 Hz and solfeggio frequencies, and partaking in sound-based treatments, we avail the chance to foster harmonic synergy in our being, potentially fostering beneficial transformations in our DNA and general wellness. To conclude, particular frequencies harbor vast prospects for transforming our DNA and augmenting our comprehensive well-being.